department is situated in that from downtown. So because normally the Indian students, they don't drive, they don't have license, they cannot drive, so they cannot have access to this building. So they have to take the buses, right? And this is in a certain area because in that place people think that everybody has a car, correct? So they don't imagine that some students don't have a car, so they have to take the bus or something like that. And because it is in a remote area, so few buses they go in the morning, and then few buses return in the evening. So if you have to in between or after hours, so either you take there's enough food and the sleep in the lab. So I have arranged a room there with a bed so that the students working in the night, those who want to work in the night, they can sleep in that. But in the night after 10 o'clock is the security rule that only single student cannot stay there. So there have to be 2 students at least. And anyway, I bought a truck also for $45,000 so for my students just for this purpose, so that they can use. But unfortunately, they cannot drive, so they cannot do that. So basically, but they do go. Okay, they do go whenever the experiments is required. We'll discuss that. Okay, because we are developing a technology from bioplastics, also from biosolids, and we will discuss that how we are using this bioplastic. So anyway, you see these, there are the 2 tanks here, this is the one and that's the one, okay, here. So basically this is the fermenter, and this is the so-called the vessel, okay. This is also a sterilizable vessel, but this is to store the fermented medium, okay. Because once the fermentation has been completed, you cannot leave it in the fermenter. So we transfer to this tank before we feed it to the centrifuge, because you have to separate the solid and the liquid, depending on if your product is in the liquid or your product is the solid. What we discussed is like trichoderma, for example. The product is in the solid phase, right? The mycelium, the spores, and everything else. So that goes to the centrifuge. So if the centrifuge is occupied, so we have to store for a certain time. Otherwise, we have a direct connection from the bottom of this fermenter, and then we take to the other side is the centrifuge. I'll come down. Right. So here you see these are the 2 smaller fermenter. Each working volume, nominal volume is 150 liter, both of them. Okay. And you see all these lines which have the insulation here. All these lines, they are the steam lines. Okay. Because you have to deliver the steam to sterilize, and the boiler is in the mechanical room, which is on the other side. You will not see that because boiler is considered as a dangerous equipment. Though it's not dangerous, it's very safe because all the safety rules is followed while it was constructed and delivered. But still, the students are students. They are there to do the mistakes all the time. So somebody has to tackle that and make sure that there are no mistakes. And you see these lines. Then these lines are the exhaust lines. Okay, exhaust like air is coming out, and it is associated with these lines, and they take the air outside the building. And the whole this lab is how do you call that? Under pressure. Okay, that is the pressure in the lab is a little bit more than the atmospheric pressure, so that the air goes out. When you open the door, the air goes out. The air does not come in. Because if the air comes in, it can contaminate your building inside, and then you may have severe problem of contamination. You may not have that experience of contamination, but it's really a very, very severe and serious problem in this industry.
So how much
those measures have been taken when this building was constructed.
Sir, how much can you centrifuge in one go?
Wow, how much?
How much amount?
I will come back. Centrifuge, if you hold on your question, please. Hold your gun, okay? If you have any question and you can bombard here right now, okay, you can do that. Okay? And you see here, this is the so-called the moving lift here. So you don't see that. There is a rail here on top of this where this moves, the lift moves with the motor driven. Because when you have to open this lid, which is a very, very heavy lid, okay, you cannot open this, okay, because you have to open it time to time to clean. Well, of course, we have a CIP system, but it's called the cleaning place. So it automatically washes the cycles and everything. So it does wash. but sometimes you have to open. When especially the foam comes into the fermenter, because especially when you ferment the sludge. Okay, if someone is going to try that for baseless fermentation, you will know that during installation there is immense foam formation and it's very hard to control. Okay, so we'll have to add some kind of polymers or anti-foam agent. But it's still okay. There is trick. Okay, when you start working, then you develop your own skills how to control those foams. So, and during the fermentation, if the foam touches the top layer, then the top plate, so in that case, the contamination is evident. You cannot avoid it. So we try to avoid not to touch the foam. And once the foam also touch another part of it, then you have to clean it because it is a little bit beyond the range of the CIP system. Though it does, okay, basically it does a type of rain type of system with pressure. Okay, and there are bulbs. Okay, and there are small openings and from all sides, and then this bulb also rotates while doing it, so it throws the water on the sides. Okay. Same thing here too. And here you see that the student is opening this. This is a manhole. So when you have to see that everything is inside, the fermenter is correct, and there are no deposits or there are no some kind of there is nothing, no possibility of being loose. But sometimes you have to open the agitator because the agitator runs from here to here to this light, and it is driven by a motor at the bottom of the reactor. Okay. So sometimes you have to replace the seal because if something has come in, the seal has corroded, because you have to continuously replace that. And each time you replace the seal, the mechanical seal, it costs us $6,000 to $7,000. Roughly $5,000 is the seal, and then another $1,000 to $2,000 for the labor. Then there are all these other lines like chilled water, deionized water, tap water, hot water, and all those kind of things. So that's all the mess of these pipelines. And then there are certain mobile tanks. They are somewhere here, hidden. Okay. So they are on the caster wheel, so we can push them. They are sterilizable. So if you have to transfer the product or if you need for certain kind of things, so you can store in them after the fermentation. Because after the fermentation, you have to get the fermenter clean immediately and then fill it with water so that your seal is safe. Because anything can damage the seal, and the seal is very important. Sorry?
Student can be mistake that day. That fermenter.
Oh yes, or water.
We'll see. We'll explain that fermenter too. Then there's the other side of the view. Okay, so I have these two parallel lines. Okay, this building. So that was another room. So this is another room. So these are the two parallel rooms that mirror image of each other. And you see this blue capsule here. So this is the air compressor chest. We call it compressor chest. That is stops air under pressure. Okay. Normally it was not supposed to be here. It was supposed to be somewhere else. But when the company was constructing this, they were supposed to construct in horizontal, okay, and then place in the mechanical room. But somehow they did a mistake, so they did vertical construction, and there was no place elsewhere because the height is very high. So ultimately we had to place it here. So it is against the norms of security, but we tried maximum to take all the security precautions. Let's say if there is a power failure or there is a compressor failure or something happens, so this guy can deliver the air for at least 5 to 6 hours, not more than that. Because if you are running 2,000 liter fermenter, the demand of air is very, very high. So it cannot be that. But we have another compressor which is called the in-situ compressor, because everywhere you need the compressed air in the lab, like in your lab also there may be compressed air, so that we can also use an emergency as a compressed air. Because if your fermenter is running, you cannot afford to put it down, and if you are running on a synthetic media in a 2,000 liter fermenter, it may cost you something like $10,000, okay, putting the fermenter down. Or if you even if you contaminate it, that means $2,000 have gone down the drain. Okay. So these are again the two fermenters here. Yeah. So these are the 250 liter fermenter, and this one is that. And this is that mobile tank I was talking to. So when you want to harvest and for a temporary time, So they have the connector, so either you can connect it to the steam line under pressure, or you can connect it to the cold water, okay, the chilled water. If you want to cool something, let's say if you have an enzyme solution, you want to store for 2-3 days, so you connect it to the chilled water line, and the chilled water will keep on circulating at 4 degrees centigrade, and the temperature it will bring down to roughly 5 degrees centigrade. So that will maintain your enzyme intact. It will not be deteriorated. Otherwise, it can get contaminated. If you have something that you want to sterilize for temporary basis, so you can hook it up to the steam, you can do it. Okay, so that's what it is. So this is this side again is a 2,000 liter fermenter here, and okay, there is another vessel too, which is behind this. Probably you don't see here, right? And then in this area here, there is a so-called killer tank, but this is underground. Because we talk always the severe norms and regulations of the municipality. You cannot dump into the sewer anything you like, as I said. You cannot dump anywhere in the forest, you cannot dump anywhere on the road, you cannot dump even in the sewer. Okay? So because this is a semi-industrial, or you can say pilot plant, so whatever is coming out, that has to be sterilized at 130 degrees centigrade according to the municipal guidelines. So after the fermentation, if we have done and we don't want to recuperate the product, just we want to throw it into the sewer lines. So first, then it goes to this the killer tank, which is underground. Okay, and then it kills. Then you sterilize at 130 and 140 degrees centigrade for about an hour, and then you discharge into the sewer lines. Every time you do any experiment in this pilot plant, that has to be followed that way. All right, now these are the small fermenter unit here. You see that this is the 5 liter fermenter here, okay? And this type of fermenter, we have 4 fermenter. In fact, this is a control unit here in the center, and another fermenter is on the other side. So basically, you can run 2 fermenters side by side. This is for the students' experiments. Some industry also comes, they want to test their strain, they want to set their media, so many things. So they can also, we make the money out of it because we rent this unit. Okay, so if industry is coming and renting, let's say one line of the fermenters, so we charge $10,000 per week, and we provide 2 technicians to take care to run the pilot plant, because anybody is coming in, so he doesn't know anything to run the pilot plant. Okay, so they have to pay the charge. Everybody, okay, that's how we say there's no free lunch. Everything has to be paid by someone, because the bill I pay for this pilot plant is something like how much is that? Roughly $80,000 to $90,000 per year for the electricity bill. Forget about rest of the things. Okay, just the electricity bill is $80,000 to $90,000, and I have to pay. This is not the university like UK. You can burn whatever you want. Okay, I have to pay. Okay. If I don't have the money, they will shut down the pilot. So that's how it works. So I have to go and dive somewhere and get that money. The annual charge, per se maintenance, record, and the 2 assistants, 1 research associate. In total, that costs us roughly $250,000 per year. So in order to maintain it, so we have to get that money. So we rent it. So and we keep on. We have been doing good. So far, so good. It was installed in 2010, 2011. We are doing fairly good. We are getting our done. Now, let's see next what is there. Okay, this is another view of these fermenters from the other side of the pipelines, and this here, the big vessel, the fermenter. I wanted to show you at the bottom, but somehow it is not very clear. So because how the system works. And okay, on this side, this lady student, she is standing on the control, not the control panel, on the meter, okay, which displays the current pH in the fermenter, and the dissolved oxygen concentration, and if there is an antifoam connected, so that also indicates antifoam, how much has gone, when it is started, when it was added, and how much it was added. Then there is a balance also that side, so if you're running it continuously, so that will tell you, okay, the meter, that how much is the weight of everything inside. So that's automatically recorded there are the records, but the control panels is on the other side. I'll show you. Okay, here we go. Here, this is a continuous centrifuge you're talking about. So this is a separate room for centrifugation, and this is attached to the 2 lines of implementation. And we connect it through a direct pipeline through the wall. There is another pipeline which passes through the wall and connect either to the fermenter directly or to the stored vessel. And that serves as a feed to the continuous centrifuge. And you see these 2 tanks here, the big ones. That one is 1,500 liter, and one is another 1,000 liters, and just to store the product, depending on what you want to store. Okay? If it is your biomass slurry, or if it is your enzyme, so it is in the supernatant. So before you go for further treatment, in the so-called downstream processing, you can store that. To design this pilot plant and to raise the money, it took me almost 3 to 4 years. Okay? So it was not easy, but it was a very good experience. And because I had an experience, I established the same type of pilot plant here in IIT Delhi. I don't know if it is working. I think Vikram was in charge.
Yeah,
After I left, Dr. Punendra Ghosh was in charge for some time, and then it was overtaken by Vikram. So I designed that pilot plant with a company in Bombay, which is called, I don't know if it exists anymore, it was Unique Biochemical Engineering. So I had already some experience, so that really helped me to work over there, and everybody was amazed how I could do it single-handedly. All right, now let's go further. Okay, so these are again the holding tanks, a clear view for beyond just on the side of the centrifuge. So these are the doors to go to those lines, and then this door here to go to the line, the 2 lines. Yeah, why there are 2 lines? Okay, that is also a story there. When I was trying to get this pilot plant, because this cost me something like $15 million, which is not a small money. And it was to be financed by 40% by the provincial government, and 40% by the federal government, and 20% by the industry. So I was trying to have many players on the board, because you cannot get as a single researcher. As I mentioned you the other day, when you go to ask any money, any grant, so you need a team of the researchers. For you alone, nobody will give you anything. Okay? So I wanted to have a very, very strong group, and at that time there was a research network. In Canada, we have different research network depending on which field. Like in SLUS, there is a network. Biocontrol that time was a network. Nowadays, bioenergy is a network. So in the network, what they do, they take all the scientists throughout this country, east to west coast. Okay, those who are leading people, those who are emerging people, that is the young faculty. So that forms a consortium, and then they go for the so-called research network. And it is financed by the federal government, and because they have the money for this. So basically, it is to foster the research in the country. And these networks are given only on the emerging need of research of the country. Okay, it is well planned and well defined, so-called the strategic area. If the government decide, but what is the government? It's all the scientists. Okay, we people decide. Okay, that okay, this is a particular research area, and Canada needs input folks in this. Okay. They ask the minister, and then he has to make the funding available. Funding is always available, but it depends on where to do that. Okay. So these are the networks. So at that time, Biocontrol network, which was dealing with all these PGP and everything. So I wanted to bring them on the board, and they said, "Oh, Tyagi, you work in sludge, and we work in pure medium, so we will always have contamination." Okay, so in order to respond to their need, I said, "Okay, fine, then we can have 2 lines." Fine. So that's why it costs us more. Okay, not us. Okay, I'm happy that I have 2 lines, but yeah, we have to work a lot for it, and then that's why the reason I have the 2 lines. So 1 line is reserved for the synthetic medium, or the pure strains, everything pure, and the other line we do all the shit experts business of this wastewater, everything. So that's the story. But my institution has to cough out more money to construct the building now, because the building area increased, and that put another burden of almost $12 million on my institution. But they went to the provincial government, and these are all political things. So because that's these are things they are dealt at the higher up level, at the vice chancellor level normally. So this. All right. Now this is we are talking about stress biodegradability. By now, I think you should be familiar with that. Am I right? So you have to use the different techniques, and we were trying to develop different techniques. And we found that what I talked this morning, thermal alkaline treatment, for example, to hydrolyze the sludge, and that sometimes you need like cellulosics come into that, so you have to take the temperature to 180 or 170 degrees centigrade. So this is basically, they are the two hydrolyzers. What we call here, this is a 2000 liter hydrolyzer, and this is a 150 liter hydrolyzer. So in these hydrolyzers, okay, we have a high pressure steam, whose temperature, high pressure compressor steam, and this temperature is normally 250 degree to 270 degrees centigrade, which raises the temperature in a flash. Okay, within 15 minutes, temperature from 30 is taken to 170 to 180 degrees centigrade, and the material is hydrolyzed. Basically, we have two systems in this hydrolyzer. One system goes into the jacket. Okay, the steam circulates in the jacket. Okay, and then increase the temperature. Let's say if the sludge is okay, if you pick up the sludge from the tank, actually sludge tank, so it's all liquid, right? So you fill it in the tank, and then you pass the steam into the jackets. If it is the water sludge, like this guy was telling us yesterday at the bottom, so this is the solid mass. So what do? You fill the solid mass and pass the steam directly. So when you pass, this is called the steam cracking. And when the steam passes, the steam condenses, and this material automatically solubilizes. So we already, we know previously that how much is the dilution factor. So we have to know that how much solids we have to charge, so that to get the desired concentration at the end of the treatment. So these are the two. They can be converted also into the fermentation with minimal expenditure. When we were constructing the plant, we ran short of money, so we did not convert them into the fermenter. But I think we will do that very shortly, because we are asking about $7 million from the provincial government, which is called the Quebec external economic development, to export the technologies. So basically, there's a cell there, and the Quebec government has put a lot of money in that. For those technologies, those are exportable, not only usable inside the province or inside the country, but those are exportable. That means that nowhere this technology exists, and then you can create a so-called the client ship, right? Clientele, and those clientele will be. So that's why this company.
So this one is just for thermal hydrolysis, or there's a for the alkaline hydrolysis also. This is just a thermal hydrolysis.
Combined. Okay, what is the
so like, do you have a port for adding the base, and a probe for measuring the pH? Because you said we need to take it up to 12 for the alkaline hydrolysis.
Yeah. Okay. For alkaline hydrolysis, you have to adjust the pH. Correct.
Right.
You adjust pH. There's a probe.
Okay.
Once you have adjusted, but that you can do only in case of the liquid phase. If it is a solid case, then you have to decide by any mo. Okay, I add so much of acid, and that will be approximately that. Right. And that the measuring rod is the addition of amount of the alkali per kilograms of dry sludge. Okay, so we calculate how much amount we are going into. So approximately we add that, and when you directly sparse the steam into it, the steam cracking, that will dissolve everything. Okay, so but you have to be very cautious, because high concentration of NaOH can corrode the polish of the vessel inside, because they are highly polished system, and if there is a small crack develops, that is very prone to the contamination, because something will be stuck there which will never be sterilized, and you are finished for it.
Sir, what about that order generated by when you are heating these things at 270 or 280 degree temperature?
Oh, good question. Okay, yeah. No, right now, that's what I was talking the other day. To control the order to buy a biofilter, and that biofilter costs about $500,000. So I decided not to buy, because I had no money to buy that. Okay. So what we are doing currently, we found a very good solution. The outgoing air, we have a tank, and we sparse it into just simple water. Okay, or sometimes we have some alkaline water into that. So basically, most of the volatiles, they get condensed into the water before you discharge the air outside. Okay. And also we have a little advantage, because our pilot plant is not situated in the city, so it is basically in an industrial area. And so if some order goes out, people are very sensitive to the order. Okay, if some little bit of order goes out, so far we have no problem. Okay, so far, but it can come any day. Okay, If the hydrolyzer is operated and something goes out, yes, certainly it can create a problem. Okay. So because it is less used, so you see that people have stored different type of cartons here, different type of things here. But we use it. Lately we use it as a fermenter to grow bacillus because it requires very low oxygen. It did not also require any pH control. So we did produce that bacillus PCPA in this, working it as a fermenter. Okay. So basically that did not require any oxygen. The surface aeration was enough. Okay. So-called the micro aerophilic conditions, and that could be maintained. Because we are looking for money every left and right, so we have to charge everywhere. So that's all right. So now this is the laboratory which caters the need of the pipe. This is not my central laboratory, but if my students they want, they can come here. Okay. And but as I said, there are very few who want to come unless the fermenter is not available in the downtown lab. Somebody is working on that, so they have to sort out and come here. Or if they are doing some scale-up experiment, so then they have to come and sort out. So this is that. So they are also my PhD students, Jaishankar and Shaoli. Shaoli is a Chinese student, one of my best students, and she published in her PhD almost 17, 18 articles, so absolutely very good articles on biodiesel. And right now she is as an assistant professor in Harbin Institute of Technology in China. And she also won the student prize, as well as we got a very big award from the American Association of Environmental Engineering. And this was the best award that anybody could get in America. And we got that award just because of her work. Okay? She was so dedicated a person that there have been only few my students in my last 34, 35 years career, and she was one of them. Now this is a ultrafiltration unit, okay, because if you are dealing with the enzyme preparations or something, you get the solution and the enzyme concentration may be 20 IU, 30 IU, 40 IU. So to recover the enzymes, you always face a problem. Either you precipitate by ion, how do you call that? Ion, no, what do you call it? Oh, I forgot the method. Where you add a lot of ammonium sulfate, common ion effect. And with that, these are all but expensive things and so on and so on. Or precipitate by other methods. Or you have to go for something else. So what do? The ultrafiltration, you separate the enzyme and concentrate the protein. Let us say you concentrate the protein from maybe 3-4 grams or 10 grams per liter to 100 grams and 50 grams per liter. And then you can precipitate. So you